In this lecture, we will learn the concept of an IDE. So, what is an IDE and why do we use it? All right, IDE is an integrated development environment. In short, IDE is a software application that provides a comprehensive set of tools for software development. IDEs typically include a code editor, a compiler or interpreter, and a debugger. They also offer additional features such as source code management systems, version control systems, and build automation tools. The main advantage of using an IDE is that it provides a single, unified interface for all tasks involved in software development. Now, this saves time and effort as developers do not need to switch between different tools or environments for various stages of the development process. IDE offers helpful features such as code completion, syntax highlighting, and error checking, making it easier to write, debug, and maintain code efficiently. There are many different IDEs available for different programming languages and platforms. Some popular IDE for Java include Eclipse, NetBeans, and IntelliJ IDEA. Now, we will be using IntelliJ IDEA for a variety of reasons in this course. IntelliJ IDEA is a popular Java integrated development environment developed by JetBrains. It is widely used by Java developers due to its extensive features and functionality. Now let's go over some of the benefits IntelliJ IDEA has to offer. Now the first one is intelligent code completion. This feature suggests variable names, methods, and classes as you type, helping you write code more quickly and accurately. The next one is advanced refactoring tools. These tools enable you to safely and easily restructure your code. Then a built-in debugger. IntelliJ IDEA includes a built-in debugger that allows you to step through your code, set breakpoints, and inspect variables. The next one is integrated version control, which allows you to integrate with version control systems such as Git and Mercurial, making it easy to manage your code base and collaborate with others. The next one is customizable user interface. Now, this feature offers a customizable user interface, allowing you to tailor it to your specific needs and preferences. The next one is great support for popular frameworks and libraries. IntelliJ IDEA provides excellent support for popular Java frameworks and libraries such as Spring, Hibernate, and Android. All right, and the last one, not the least, is regular updates and improvements. JetBrains actively develops and improves IntelliJ IDEA, releasing new versions regularly. All right, to summarize, let's compare the IDE to a text editor. An IDE typically includes a code editor, compiler, and interpreter and debugger, right? Providing a comprehensive set of tools for full software development lifecycle. Now, in contrast, a text editor is a simple program for creating and editing plain text files and does not include all these IntelliJ IDEA or IDE cool features. All right, next one is IDE offers features such as code completion, which we covered, syntax highlighting, error checking, while text editor may have only basic features like syntax highlighting and code folding. All right, another one, IDE may include tools for source code management, version control, and build automation. Now, whereas a text editor lacks many of these tools and features. Then an IDE is usually more feature rich and may have a steeper learning curve, while an editor is a simpler and easier tool to use. All right, that's about it. I hope this explains why we will be using an IDE rather than a text editor.
Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
In this lecture, we will discuss installing IntelliJ IDEA on Windows. This lecture is specifically for Windows users. Linux users should refer to the separate lecture on installing IntelliJ IDEA for Linux. Now let's download and install the IntelliJ IDEA so we can write our Java programs. Now for that, I want you to go open your browser and go to jetbrains.com. Click on the Developers Tools tab at the top and then click on IntelliJ IDEA. Then click the download button. Ensure that Windows is selected and choose the Community Edition of IntelliJ IDEA to download. The Ultimate Edition is a paid version and it is not necessary for this course. All right, once the .exe file begins to download, wait for it to complete. By the way, this is the executable file. After the download is complete, double-click the .exe file to open it and begin the installation process. When the installation wizard appears, click Next to accept the terms and license agreement. Then choose the destination folder where you want to install IntelliJ IDEA, then click Next. Then select the components you want to install. Make sure to select IntelliJ IDEA Community Edition and then click Next. All right, then you click Install to begin the installation process. This may take a few minutes, of course. Now, once the installation is complete, then you can click on Finish. IntelliJ IDEA is now successfully installed on your Windows system. In the upcoming lectures, we will explore its features or functionalities and start working with it. I hope you found this lecture helpful when it comes to downloading and installing IntelliJ IDEA, which is an IDE tool. In this lecture, we will cover the installation of IntelliJ IDEA on CentOS Linux. Let's get started. I'm currently setting up a virtual machine in VirtualBox on Windows with CentOS Linux as the operating system. I'm also connecting to CentOS using PuTTY, which is available for Windows. Please note that PuTTY allows you to connect to your Linux machine from a Windows operating system. Okay, so first thing we need to do is log in as root on our Linux machine and then enter root password to proceed. To download IntelliJ IDEA from a CentOS terminal, we first need to enable snaps on CentOS. So let's run the command sudo yum install apple epel-release. Now please note you do not need sudo command if you are logged in as root. Also, if you're using the newer version of CentOS, you could use dnf command instead of the yum command. Nevertheless, let's move on. So this command installs the extra packages for Enterprise Linux, EPEL, which is often referred or pronounced as Apple repository. It may take a few minutes to complete the installation. Next, install the systemd unit that manages the main snap communication socket. All right, to do that, run the command sudo yum install snapd. Again, it may take some time to install. Next, let's enable and start the snapd.socket service by running the command sudo systemctl enable --now snapd.socket. After that, to enable classic snaps support, run the command sudo ln, which is the command for link, then -s option, and /var/lib snapd/snap, and then /snap. If you have already enabled snaps on Linux, you can directly download IntelliJ IDEA from the Linux terminal using that command. All right, and that is sudo snap install IntelliJ IDEA community space dash dash classic. If you encounter an error message that says too early for operation, device not yet seeded, or device model not acknowledged, simply run the command again. The installation may take some time to complete. All right, all done. In this lecture, we will learn the functionality of IntelliJ IDEA and begin writing some Java code. This lecture is beneficial whether you are using Windows or Linux. To get started, we must first associate the JDK Java Development Kit. I have installed IntelliJ IDEA with Oracle's JDK 17 to make them compatible. Essentially, this means informing IntelliJ of the presence or absence of a JDK on the system. In general, the JDK functions as a software development kit and provides all the resources we need to develop programs. The JDK includes tools necessary for a computer to recognize and run our Java code. It also contains a debugger, which we will explore in more detail after developing a program to use it. If you haven't started IntelliJ IDEA already, please go ahead and do so. The first step is to acknowledge the user agreement by checking the box, though it is recommended to read it first. The next step involves the data sharing options. Once IntelliJ IDEA starts, you will see a welcome screen with options to create a new project, open an existing project, or get a project from VCS, which is short for version control system. All right, new project. This option allows you to create a new project from scratch. You can choose the type of project, such as Java or Kotlin, and configure various settings. Then open this option allows you to open an existing project that you have already created or downloaded. And then the third option is get from VCS. This option allows you to check out a project from version control systems such as Git or Subversion. You will need to provide the repository URL and the necessary authentication information to clone the project. All right, let's start by selecting new project. You will see a JDK detection pop up in IntelliJ, looking for the JDK installed earlier. If you look closely, the version number should match the JDK you previously downloaded. In my case, it is version 17.0.5. If you haven't installed the JDK, please refer to the relevant lecture on JDK installation before proceeding. The next step is to verify that Java and IntelliJ are selected and that the correct JDK is displayed. This is the screen you will use frequently when starting a new project. Once you are back on the main IntelliJ screen, click the Cancel button. This time, click Customize to adjust a few things. Then click Settings to change the theme. The document background is a popular choice for programming as it is gentle on the eyes, of course. However, I will select IntelliJ Light as the white background can be more comfortable for us. Remember, you can return to this menu to change the setting at any time. Okay, next go to Editor and then General. Here we can simplify things for beginners Java programmers. I will enable Auto Import. This feature automatically adds missing import statements when you use a symbol. For example, a class or method that cannot be resolved. It helps avoid manually adding import statements. The auto import feature is enabled by default, but you can disable it if you prefer to add imports manually. Check both add unambiguous imports on the fly and optimize imports on the fly. Add unambiguous imports on the fly automatically adds import statements for symbols used in your code, while optimize imports on the fly removes unnecessary imports, and reorders the remaining ones to keep your code clean and organized. Next, we will move on to the code folding. Since IntelliJ IDEA is a professional editor designed to simplify coding for both beginners and experts, some default parameters may hide parts of the source code. To view all the code, deselect options such as imports, file headers, one-line methods, closures, and generic constructor and method parameters. This ensures IntelliJ displays as much as code possible. All right, now go to Appearance and ensures that Show Line Numbers is checked. With the settings complete, click OK. To return to Projects page, simply click Projects. Here, any completed projects will be listed, making it easier to access them later. Since we have no projects at the moment, let's create a new one. Click New Project. Next, provide IntelliJ with the information about the project you wish to create, including the project name, location, and language. The JDK set to Java should automatically default to the version we defined earlier. Enter the project name, such as, for example, my first program. Avoid using spaces in the name, as it can cause issues with file path. To differentiate terms, you can capitalize the first letter of each word. For example, my first program, where my is the uppercase, F and P are the uppercase, as a style known as Pascal case. Pascal case or upper camel case capitalize the first letter of each word, including the first word. For example, upper camel case. Lower camel case, often referred to simply as camel case, capitalizes the first letter of each subsequent word, while the first word remains a lowercase. For example, lower with L lower, camel case. Following naming convention like these improves code readability and clarity. That's why it is important that you understand these terms and these cases. Next, specify the project location. IntelliJ uses a default location, which is tilde backslash IDEA projects on Windows and Linux systems. But you can choose a different folder if you prefer. The tilde symbol represents your home directory, and IDEA projects is the default directory for IntelliJ projects. For example, on Linux, it might be /home/john/IDEA projects. And on Windows, it might be C drive or C:\users /John /IDEA projects. You can change this location if you want to. There is an option called sample code. If selected, IntelliJ will include sample files and code to help you get started. This can be useful for understanding IntelliJ's features and code structure. However, if you want to start with a blank project or use your own files, uncheck this option. We will uncheck it and press create. Your new project will appear on the left-hand side. Click the little arrow icon to open or close the folder. Below it, you will see a .idea folder which contains IntelliJ configuration files. You can ignore these for now. To create your first Java class, right-click on the SRC source folder, select New, then click Java class. Enter Hello World as the class name and press Enter. IntelliJ generates some basic code for you. The editor window will display the generated code with Hello World label as a class in the left pane. To add code, place your cursor at the end of the line and press Enter. To reduce typing, use the IntelliJ shortcut PSVN, which is in short for Public Static Void Main, and press the Tab key. IntelliJ will automatically generate the main method. Use system.out.println line parentheses hello world parentheses semicolon. And of course, put the double quote around hello world. Now, this will print hello world to the console. Remember to end each statement with a semicolon. To execute this code, click the green button at the top right or the green arrow to the left. You can also right-click and select Run. IntelliJ uses the JDK to build and execute the Java program, displaying the output "Hello World" in the running pane. The process finishes with an exit code of 0, indicating a successful completion. Yep, beautiful. We have successfully executed our Hello World Java program in IntelliJ IDEA. In this lecture, we will learn the Hello World program in IntelliJ IDEA. In the previous lecture, we executed our first Java code in IntelliJ. Now, let's take a closer look at the source code for this class as it is displayed in IntelliJ. You will quickly notice that the code is formatted with a variety of fonts and colors and is well indented. Whenever we create text in a file, IntelliJ automatically formats it for us. When examining the code, you will see elements such as public and class. The public keyword is an access modifier that controls the access level of a class, method, or field. When a class is declared with the public keyword, it means that the class can be accessed from anywhere in the code, whether within the same package or from the other packages. Access modifier help define which part of our code or someone else's code can access a particular element. Okay, now the class keyword is used to define a new class in Java. The class name follows this keyword. A class acts as a blueprint for creating objects with specific data structure, providing initial values for state members variables, which is fields, and implementing behavior member functions, methods. The left and right curly braces define a class body containing the field and methods that make up the class. Anything inside these curly braces is considered a part of class definition. The class definition may also have an optional access modifier at the beginning, such as public in this case, which grants full access as described earlier. This overview will be expanded later when we discuss access modifier and class definition in more detail. Everything inside the curly braces belongs to this class. As we progress through the course, you will see that a class can include both data and code. In this case, we have a clear definition of our first class and our first project. You can also see that this class contains a main function that prints the hello world message. Before diving into that, let's define a method. A method is a group of statements that perform an action. A main method is a special method that Java searches for when executing a program. It serves as an entry point for all Java code. Whenever we run a Java program, Java looks for the main method to launch and execute the application. Later, you will learn how to create your own methods. All right, let's discuss the method and the keywords preceding the method name main. The first keyword is public, which we already covered when defining the class. It allows the other code to access this function. To fully understand the Java keyword static, you need familiarity with other object-oriented concepts. For now, just know that static is necessary for Java to locate and execute this specific method. All right? Okay. The next keyword, void, indicates that the method will not return any data. We will explore this in more detail later. The parentheses are required for a method declaration, and we are defining a method by including this code. You can optionally specify one or more parentheses inside the parentheses to provide information to the method. Here you see one parameter, which we will discuss in more detail later. The main method must be written exactly as shown, with its syntax carefully followed for Java to recognize it. If you change anything, such as using an uppercase C in the word class, IntelliJ will underline it in red, indicating that it does not recognize the term. That's why it's intelligent. Correcting it back to lowercase c resolves the issue. Be aware of this, as errors often stem from incorrect capitalization. The left and right curly braces used to group statements together, as discussed in the J shell lecture, also appear in the main method declaration. This grouping is known as code block, which in this case defines the beginning and end of the method. You can insert code statements within this block. For practice, let's change the hello world statements to hello Nixware Company and run it. It's just a made up company. You can see the updated output. Next, let's create another class in IntelliJ. Right click on this src folder in your project. Select new and then choose Java class. Enter the name, my class, and press enter. You will see my class listed under the src folder with a small blue uppercase C icon indicating it is a class. In the editor window, you will see the class name, my class, and the curly braces for the class body. Let's add two print statements. First, write the method declaration: public static void main parentheses string bracket open bracket close, then arguments parentheses closed, followed by an opening curly brace. Then add the following statement: system.out.print parentheses double quote hello comma space nixware double quote parentheses close and semicolon. Then the next line is system.out.print parentheses double quote American company double quote parentheses and semicolon. Close the curly brace. When you run the code, both messages will be printed on the same line. To print, for example, Nixware Company on a new line, change the first print statement to system.out.print line and then put that Nixware in it. The ln, or short for line, in print ln moves the cursor to the next line. Yep. So that's it. In this lecture, we will discuss conditional statements, which are if-then statements in Java. The if-then condition is used to control the flow of a program's execution. It allows developers to make decisions within the program based on certain conditions or circumstances. It is also known as conditional logic. So conditional logic in Java refers to the use of if-then statements and related construct to control the flow of a program's execution based on certain conditions. These statements allow a program to make decisions and take different actions depending on the current state or input. One common use of the if-then condition is to check the input values entered by the user to ensure they are valid before performing any further processing. For example, if an application prompts the user to enter a number between 1 and 10, the program can see an if condition to check if that number entered by the user is indeed within the range before proceeding. Another common use of the if condition is to make decision based on the current state of the program. For example, a program may use an if condition to check if a variable has reached a certain threshold before taking a specific action. The syntax of an if-then statement is the if keyword is used to start the statement, followed by a set of parentheses that contain the condition that is being evaluated. The condition can be any expression that returns a Boolean value true or false. If the condition inside the parentheses evaluates to true, then the code within the curly braces that follow is executed. These curly braces enclose the code block that will be executed if the condition is true. Any number of statements can be put inside the if block, but it should be noted that the code inside the if block is executed only if the condition inside the if statement is true. Now, there are several advantages of using if condition in Java. All right, like conditional execution. If conditions allow for conditional execution of code, meaning that certain statements or block of code are executed only when a specific condition is true, which we already discussed, right? This allows for a more efficient use of resources and can make a program more versatile and adaptive to different situations. Then there is improved readability. If conditions can make the logic of a program more explicit and easy to understand. By using if conditions to separate the different branches of a program's logic, it becomes easier to see how the program is functioning and how it handles different inputs and scenarios. All right, then let's look at the better handling's advantage. If condition can be used to validate input to check for error conditions that may arise during the execution of a program. This allows for better error handling, which can make a program more robust and less prone to crashing. Okay, another one is enhanced flexibility. By using if else statements, developers can create more complex decision making logic, allowing for the program to handle multiple conditions and scenarios. All right, let's look at another advantage, which is reusability. If conditions can be used to create functions that can handle different conditions and inputs, and these functions can be reused in different parts of the program. This can save time and make the code more efficient. All right, in short, if conditions are a powerful tool for controlling the flow of a program's execution, making it more versatile and adaptive, also improving the code readability and reusability, making it more robust to handle different scenarios and errors. Also, there are a few potential limitations to using if conditions in Java, which I think we should look at as well. The first one is complexity. Using a multiple if condition in a program can make the code more complex and harder to understand, especially if the conditions are nested or involve multiple branches. This can make the program more difficult to debug and maintain. Then another limitation is performance. If a program has a large number of if condition, the execution time may become a bottleneck. Yep, and it can decrease the program performance, especially if the conditions are complex. This can slow down the program's execution time. Then repetitive code. Using too many if conditions can lead to repetitive code, making it harder to maintain and change the program. Then there is a limitation of readability. If the conditions and the code inside if statements are very complex, it can make the code less readable and harder for the developers to understand. All right, then let's look at neglecting other options. If the code is heavily reliant on the if condition, it can lead developers neglecting other options, like using different data structures or solving the problem in a different way. It is important to keep in mind that While if conditions are a powerful tool for controlling the flow of a program, they can also make the code more complex and harder to maintain if used excessively or in a disorganized manner. It is important to be mindful of the trade offs when deciding to use if conditions and make the best decision according to the context. That is why I included both advantages and its limitations. Now we come to some practice for if statements. For this, open IntelliJ. Here we create a class file named conditions. After creating this class file, add a main method to this class as we discussed in the previous lectures. Now we make a simple example of using an if condition with a Boolean expression in Java. Now we declare a variable named flag and assign it the value of true. The next is if statement, which checks the value of the variable flag, which evaluates to true because it was previously assigned the value true. If the condition inside the if statement is true, then the code within the curly braces that follow is executed. In this case, the code within the if statement block is system.out.println parentheses double quote flag is true semicolon. This line of code calls the println method of the system.out object, which is used to print text to the console. The text that is output is flag is true. Therefore, when this code runs, it will output flag is true to the console because the variable flag is assigned the value true. And therefore, the if statement condition evaluates to true, and the code within the if statement blocks is executed. Now you can see the output here. Now we see another example. For this, we create a new class file. This is a great practice for beginners and it makes the code easier to read and learn. So write the class name condition1, same as previous example. First create a main method here. Now we first declare a Boolean variable user and assign it the value of true. Then the if statement checks if the value of the variable user is equal to true by using the equality operator, that is equal equal. The condition inside the parentheses is user equal equal true, which compares the value of user with the Boolean literal true. If the condition inside the if statement is true, then the code within the curly braces that follow is executed. In this case, the code within the if statement block is system.out.println parentheses double quote it's true semicolon. This line of code calls the println method of the system.out object, which is used to print a text to the console. And the text that is output is it's true. Okay, therefore, when this code runs, it will output it's true to the console because the variable user is assigned the value true. And therefore, the if statement condition evaluates to true and the code within the if statement block is executed. Now you can see the output here. Now we see another example. For this, we create a new class file named condition2. Now first we create a main method here. We first declare an integer variable x and assign it to the value of 5. Then the if statement checks if the value of the variable x is greater than 0 by using the greater than operator. The condition inside the parentheses is x greater than 0, which compares the value of x with the integer literal 0. If the condition inside the if statement is true, then the code within the curly braces that follow is executed. In this case, the code within the if statement block is system.out.println parentheses double quote x is positive semicolon. This line of code calls the printline method of the system.out object, which is used to print text to the console. The text that is output is X is positive. It's important to note that if the condition inside the if statement is false, the code within the if block will not be executed, and the program will continue executing the next statement after the if block. In this lecture, we will discuss logical operators in Java. In the previous lecture, we discussed the if-then condition and used some operators to learn the concept of the if-then condition. Now we will learn the logical operator and see how we could use it. In Java, logical operators are used to perform logical operations on Boolean expressions. They are used to combine multiple conditions in an if statement or a loop or to negate a Boolean value. The logical operators that are available in Java are AND operator. This operator is used to check if both the conditions are true. If both conditions are true, then the entire expression returns true. The next one is OR operator. This operator is used to check if either of the conditions is true. If any one of the conditions is true, then the entire expression returns true. Yep. Okay. The next one is a NOT operator. This operator is used to negate a Boolean value. If a condition is true, then the NOT operator will make it false, and vice versa. Some other include working with bitwise logical operators such as bitwise and bitwise OR operators. In Java, bitwise logical operators are used to perform operations on individual bits of a binary number. These operators work on a binary representation of the numbers and allow you to manipulate the bits directly. Bitwise logical operators are typically used in a low-level programming, such as working with hardware devices or in performance-critical code, when manipulating the bits directly can be faster than using the higher-level operators. It's also used in some cases where bit manipulation is needed, such as in encryption and compression algorithms. So we will discuss bitwise logical operators later. Logical operators are important in Java because they allow you to create complex conditional statements and control the flow of execution of your program. They allow you to check multiple conditions and make decisions based on the result of those conditions. They can simplify complex expression by breaking them down into smaller, more manageable parts. They also make your code more readable and maintainable. Logical operators are also useful for improving the performance of a program, as they allow you to evaluate multiple conditions in a single statement and avoid unnecessary computation. Furthermore, logical operators are versatile and can be used in a wide variety of situations, such as in if-else statements, while loops, and for loops. This makes them a powerful tool for programmers to use in many different types of applications. So, there are a few potential limitations of using logical operators in Java as well, like complexity. Logical operators can make code more complex and harder to understand, especially when multiple conditions are combined in a single expression. Also, error prone. Logical operators can be difficult to use correctly, and using them incorrectly can lead to bugs and errors in your code. Also, performance. Using too many logical operators can slow down the performance of a program. So remember that. Then there could be confusion, where logical operators can be confusing to new programmers, especially if they are not familiar with the rules of Boolean logic. And then also it has some limited functionality, like not able to perform all the logic manipulation. It only performs the basic logic manipulation, and other complex logic manipulation requires other techniques. Now we come to some practice, okay? So for this, open IntelliJ. Here we create a class file named logical operators. Now we declare an integer variable named age and assign it to the value of 18. Then use the if statement to check if the value of variable age is greater than 18. The if statement starts with the keyword if followed by a condition in parentheses, in this case age greater than 18. This condition is checking if the value of age is greater than 18 using the greater than symbol operator. If the condition is true, the code inside the curly braces will be executed. In this case, the code inside the if statement is a simple print statement that prints out condition is true to the terminal or your console. If the condition is false, the code inside the if statement will not be executed and nothing will be printed to the console. Now you can see the output here. Next, we declare another string variable named gender and assign it the value of male. If the statement starts with keyword followed by a condition in parentheses, in this case gender equal male, the condition is checking if the value of gender is equal to male using the equality equal operator. If the condition is true, the code inside if statement will be executed. The code inside the if statements is simple print statement that prints out condition is true. In this case, since the value of gender is male, this if statement is met, right? So the code inside the if statement will be executed and the output will be condition is true. Yep. Now you can see the two outputs here. First for upper if statement and second for below if statement. And now we use AND operators to combine these two conditions into one if statement. For example, if we want to check if the age is equal to 18 and the gender is equal to male, then output is given, and that is eligible. First, we will comment on these print method statements because we want only the last generated output. So we use already created variables from the above, which are age and gender. The if statement starts with the keyword if followed by a condition in parentheses. In this case, age greater than 18 and operator gender equal double quote male. The condition is checking if the value of age is greater than 18 and if the value of gender is equal to male using the and equal operators respectively. The ampersand or and operator is used to check if both conditions are true. If both conditions are true, the code inside the if statement will be executed. The code inside the if statement is a simple print statement that prints out eligible to the console. If either of the conditions is false, the code inside the if statement will not be executed and nothing will be printed to the console. Now you can see the output here. See another example. For this, we create a class file named logical operators 1. Now we declare one integer variables, a, b, c, and d, and initialize them with the value 10, 20, 20, and 0 respectively. The if statement starts with the keyword if followed by a condition in parentheses. In our case, parentheses a less than b, and operator parentheses b equal c. The condition is checking if the value of a is less than b and if the value of b is equal to c using less than and equal operators respectively. The AND operator is used to check if both conditions are true. If both conditions are true, the code inside the if statement will be executed. The code inside the if statement assign the sum of the variables a, b, and c to the variable d and prints out. The sum is along the value of d. Then if statement will be executed because the values of a and b are 10 and 20 respectively, and b equal c, which is 20. So the result will be the sum is 50. Now you can see the output here. It's a simple example of how a logical operator can be used to check multiple conditions in a single statement and perform different actions based on the outcome. It's a good practice to initialize variables with meaningful values. This will help to improve the readability and maintainability of the code. In this lecture, we will discuss assignment operators in Java. In Java, assignment operators are used to assign a value to a variable. The basic assignment operator is equal to, which assigns the value on the right side of the operator to the variable on the left side. For example, integer x equal 5 semicolon. It assigns the value of 5 to the variable x. In Java, there are common assignment operators like equal, which is basic assignment operator, which assigns the value on the right side of the operator to the variable on the left side. Then there is plus equal, which is addition assignment, which adds the value on the right side of the operator to the variable on the left side and assigns the result to the variable. Then there is minus equal, which is a subtraction assignment, which subtracts the value on the right side of the operator from the variable on the left side and assigns a result to the variable. Then the next one is multiply equal, which is a multiplication assignment, which multiplies the value on the right side of the operator by the variable on the left side and assigns the result to the variable. Then there is divide equal, is division assignment, which divides the variable on the left side by the value on the right side of the operator and assigns the result to the variable. Then there is modulus equal, which is a remainder assignment, which calculates the remainder when the variable on the left side is divided by the value on the right side of the operator and assigns the value to the variable. Okay, now let's look at several advantages of using assignment operator in Java, like conciseness. Assignment operator allows you to perform an operation and assignment in a single step, which can make your code more concise and easier to read. Yep. Then also improve readability. Using shorthand assignment operators can make your code more readable by clearly indicating the intent of the operation. For example, the statement x plus equal 10 is more clear than x equal x plus 10, right? Okay. The next one is increase efficiency. Assignment operator can increase the efficiency of your code by reducing the number of operators that need to be performed. Then there is chaining. Assignment operator can be chained together to perform multiple operations on the same variable in a single line of code, which can also improve readability and conciseness. Not to forget, there has reduced errors. Yep, assignment operator can reduce the number of errors in your code by making it less likely that you will accidentally use the wrong operator or forget to update a variable. Then the last one we'll talk about is avoiding unnecessary variables. In some cases, the assignment operator can be used to avoid the need for additional variables, making the code more efficient and easier to read. Okay, now we come to some practice. For this, as always, I want you to open IntelliJ. Here we create a class file named assign operator. Now we declare an integer variable named x, and then a variable x is assigned the value of 10 using equal assignment operator. The statement x plus equal 5 semicolon use this shorthand addition assignment operator to add the value of 5 to the current value of the variable x, and then assigns a result to the variable x. In this case, the original value of x is 10 and the operation x plus equal 5 semicolon is equivalent to x equal x plus 5 semicolon. So the value of x after this operation will be 15. So we already discussed these entire assignment operators in our previous arithmetic operators lectures, right? Now we discussed the difference between equal sign and equal to operator. Now in Java, the assignment operator equal is used to assign a value to a variable, while the equal to operator equal is used to compare the value of two variables or expressions. For example, we are declaring two integer variables, x and y, and initializing with the value of 5 using assignment operator. Then use an if statement and the equal to operator compares the value of two variables x and y and returns a Boolean value, true or false. This operator compares the value of the variable x and y on the left and right side of the operator. If the values are equal, the code inside the if statement will execute and print both are equal. and that goes to the console. So in this case, both x and y are assigned the value of 5 before the comparison. So the condition x equal y is what? True. Yep. And the code inside the if statement will execute, resulting in both are equal being printed on the console. Now, let's see another example. We declare a Boolean variable z and initializing it with the value of true. Then we use an if statement to check if the variable z is equal false. You can see that we use the equal assignment operator in if statement rather than the equals to operator. What it means here is it's assigning the value false to the variable z, and the assignment operator returns the value that is assigned, which is Boolean false in this case. So the if statement will always evaluate to false, and the code inside the if statement will never be executed. This will lead to program not printing anything to the console. That is to say, the value is assigned without being compared, as you can see the output. In this lecture, we will discuss comparison operators in Java. In Java, comparison operators are used to compare two values and return a Boolean value true or false, indicating the result of comparison. These are the most commonly used comparison operators in Java: equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. They are used in many different ways in Java, such as conditional statements. Comparison operators are often used in conditional statements such as if-else, switch case to make decisions based on the comparison result. Then looping. Comparison operators are used to control the flow of loops, such as while, do while, and for loops. Also for searching and sorting. Comparison operators are used to search and sort data in arrays, lists, and other data structures. Moving on to comparison of objects. Comparison operators can be used to compare the properties of two objects and determine their relative order. The next one is checking the type of an object. Instance of operator is used to check if an object is an instance of a class or an interface. Then there is debugging and testing. Comparison operators are also used in debugging and testing to check the statement of a program and ensures that it is working as expected. All right, moving on, comparison operators in Java have several advantages, and I wanted to cover both advantages and disadvantages real quick. All right, the first one is simplicity. Comparison operators are easy to use and understand, enabling direct value comparison for more readable and maintainable code. Then flexibility. They work with various data types such as integers, floats, strings, and objects, making them highly versatile. Then another advantage is conditional control flow. Comparison operators allow decision making based on comparison result, leading to dynamic and flexible code. And the last one in advantages is searching and sorting. They facilitate efficient data searching and sorting in arrays, lists, and other structures, making data organization straightforward. All right, now let's look at some of the disadvantages. And the first one is limited functionality. Comparison operators only handle simple comparisons, making complex tasks more verbose and harder to read. Then there is inconsistency. They may behave unexpectedly across data types, like when comparing strings and numbers. Then there is overuse. Excessive use can complicate code readability and maintenance. Moderation is the key. All right, the next disadvantage is inability to compare certain data types. Yep, some types like NaN cannot always be compared. Then the restricted object comparison. Only exposed properties of object can be compared. And the last one is not ideal for complex tasks, which is for more complex comparisons, other methods are often better suited. All right, that's about advantages and disadvantages. Now let's do some practice. For this, I want you to open IntelliJ. Here we create a class file named comp operator. Now we declare three integer variables x, y, and z and assigns them initial values. The variable x is assigned the value of 5, variable y is assigned the value of 3, and the variable z is assigned the value of 4. Then the if statement checks if the condition x greater than y and x greater than z and the AND operator is true. This means that x should be greater than both y and z for the if statement to evaluate as true. The AND operator is used to check if two conditions are true. If both conditions are true, the overall result is true. Otherwise, the result is false. In this case, the first condition is x greater than y, and the second condition is x greater than z. If the condition x is greater than y and x greater than z using AND operator is true, meaning that x is indeed greater than both y and z, then the code inside the if statement will execute and it will print x is the largest number. Here is the output. Okay, now let's see another example. In this example, we use if statement that only evaluates as true if score is greater than or equal to 80 and smaller than or equal to 95. If score is greater than 95 or smaller than 80, the inside the if statement won't execute. For this, we declare a variable score as an integer and assign it an initial value of 85, and another variable grade as a string. Then the if statement checks if the condition score greater than or equal to 80 and operator smaller than or equal to 95 is true. This means that score should be greater than or equal to 80 and less than or equal to 95 for the if statement to evaluate as true. The AND operator is used to check if two conditions are true. If both conditions are true, the overall result is true. Otherwise, the result is false. In this case, the first condition is score greater than or equal to 80, and the second condition score less than or equal to 95. If the condition score greater than or equal to 80 and operator smaller than or equal to 95 is true, meaning the score is between 80 and 95, inclusive. Then the code inside the if statement will execute, and it will assign A to the variable grade. And the print method outputs the grade variable result on the screen, here as you could see it. In this lecture, we will learn the ternary operator in Java. So the ternary operator is a shorthand way of writing an if-else statement. It is the only operator in Java that operates with three operands, which is why it is often referred to as a conditional operator. The ternary operator is a concise way of performing conditional checks. It uses the syntax condition, question mark expression 1, colon expression 2, and closes with semicolon. If the condition evaluates to true, the value expression 1 is returned. Otherwise, expression 2 is returned. Let's consider an example. The ternary operators to determine the value of a variable based on an age condition. We have an integer variable age with the value 20. The ternary operator checks if age is less than 18. If true, it assigns underage to the status variable. Otherwise, it assigns senior or, adult, whatever you want to pick. Since age is 20, the condition is false. So the value senior is assigned to the status and printed to the console. In another example, we use a ternary operator to determine a pass or fail result based on the marks variable. The value of marks is set to 50. The ternary operator checks whether marks are greater than 40. If the condition is true, it assigns pass to the result variable. Otherwise, it assigns fail. Since the value of marks is 50, which is greater than 40, the condition is true, so the pass is assigned to the result. The output message confirms you passed the exam. All right, that's great. But folks, don't get 40 or 50. I want you to get more than that, close to 80% mark. And I know you will. Okay. Finally, let's consider a case where we check whether a number is positive or negative. The variable number is assigned the value 24. The ternary operator checks if the number is greater than 0. If true, it assigns positive number to the result variable. Otherwise, it assigns negative number. Since the number is 24, the condition is true, so the value positive number is assigned to the result and, of course, printed to the console. In this lecture, we will practice some of the operators questions in Java. In the previous lectures, we discussed several types of operators that can be used to perform various operations in a program. These are like arithmetic operators. These include basic mathematical operations such as addition, subtraction, multiplication, division, and modulus, increment, decrement. Then there is comparison operators, right? Those operators are used to compare values such as equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to operators. They return a Boolean value of true or false, right? Okay. Also, logical operators, don't forget that. These operators are used to combine multiple conditions in a logical expressions such as and, or, not. Then there are assignment operators that we talked about. These operators are used to assign a value to a variable, such as the equal sign, or to perform a mathematical operation on a variable and assign the result, such as addition assignment, subtraction, multiplication assignment, division assignment, and remainder assignment operators. Then the last one we talked about is the ternary operators. These operators provide a shorthand way of writing an if-else statement using the format condition question mark expression 1 colon expression 2. Okay, now for some practice. For this, open IntelliJ. Here we create a class file named challenge1. Now see the first challenge, that is, how can I check if a number is within a certain range using logical operators? For this, we declare a variable called num and assign it to the value 15. Then use if statement. It checks the condition inside the parentheses, which is num greater than 10, and operator num less than 20. The ampersand operator is used to check if both conditions are true. In this case, the first condition being checked is num greater than 10, which is true because the value of num is 15, which is greater than 10. The second condition being checked is num less than 20, which is also true because of the value of num is 15, which is less than 20. If both conditions are true, then the code inside the curly braces will be executed. In this case, it is a single line of code that prints out a message that is the number is within the range of 10 to 20. Now we see that output. Excellent. Okay, so now we see another challenge, that is, how can I use the OR operator to check if the variable is equal to multiple values? Okay, for that we create file name challenge2. Now we declare a variable called val and assign it the value of 5. Then use if statement. It checks the condition inside the parentheses, which is val equal to operator 3 or operator val equal to operator 5 or operator val equal to operator 7. The pipe or operator is used to check if at least one of the condition is true. In this case, the first condition being checked is val equal to operator 3, which is false because the value of val is 5, which is not equal to 3. The second condition being checked is val equal to operator 5, which is true because the value of val is 5, right, which is equal to 5. The third condition being checked is val equal to operator 7, which is what? False, right? Because the value is 5, not 7. So, if any of the condition is true, then the code inside the curly braces will be executed. In this case, it is a single line of code that prints out a message that is the value is 3, 5, or 7. Here's the output. Now see another challenge, that is, how can I check if one variable is less than or equal to another? For this, we create a class file named challenge3. Now we declare a variable called num1 and assign it to the value of 10. Then declares a variable called num2 and assign it to the value of 15. Then use if statement. It checks the condition inside the parentheses, which is num1 less than or equal to num2. The less than or equal to operator is used to check if the value of num1 is less than or equal to the value of num2. In this case, the value of num1 is 10 and the value of num2 is 15. And 10 is less than 15, so the condition is true. If the condition is true, then the code inside the curly braces will be executed. In this case, it is a single line of code that prints out a message num1 is less than or equal to num2. Here is the output. All right, now let's look at more complex challenge statement. That is, write a Java program that declares and assigns a value to three variables, x, y, and z. Using an if statement, check if the value of x is greater than 20, and either the value of y is less than 30, or the value of z is greater than 30. Okay, if the condition is true, print the message, the condition is true. For this, we create a class file named challenge4. Now we declare a variable called x and assign it to the value of 25. Then declares a variable called y and assign it to the value of 30. Then declares a variable called z and assign it to the value of 35. Then use if statement to check the condition inside the parentheses, which is x greater than 20 and operator parentheses y less than 30 or operator z greater than 30. The first part of condition x greater than 20 is a relational operator that checks if the value of x is greater than 20. In this case, the value of x is 25, which is greater than 20. So this part of the condition is true. All right, the second part of the condition is parentheses y less than 30 or operator z greater than 30, which is a logical OR operator that checks if either of the condition inside the parentheses is true. The first condition y less than 30 is a relational operator that checks if the value of y is less than 30. The value of y is 30, which is not less than 30. So this part of the condition is what? It's false. The second condition z is greater than 30 is a relational operator that checks if the value of z is greater than 30. The value of z is 35, which is greater than 30. So this part of the condition is, of course, true. All right, the logical AND operator combines two parts of the condition and checks if both are true. Since the first part of the condition is true and the second part is true, the overall condition is true. If overall condition is true, then the code inside the curly braces will be executed. In this case, it is a single line of code that prints out the message that is, the condition is true, and you can see the output. Now let's look at a more complex challenge statement. Yep, I want you to keep trying it and keep checking it out through these practices. Okay, write a Java program that declares and assigns value to two variables, A and B, using the ternary operator. Assign the value of a string variable result based on whether the value of A is greater than B or less than B. Then prints the value of the result variable. For this, create a class file named challenge5. Now we declare a variable called A and assign it the value of 5. Then declares a variable called B and assign it to the value of 10. Then write string result equal parentheses A greater than B question mark. A is greater than B colon. A is less than B semicolon. The ternary operator is used to assign the value of the result variable based on the outcome of the expression. Then use ternary operator statement. It checks the condition inside the parentheses, which is a greater than B. The condition being checked is a greater than B. If the condition is true, the value of the result variable will be A is greater than B. If the condition is false, the value of the result variable will be A is less than B. In this case, the condition is false. The last line of code prints the value of the result variable. So here is the output. I hope you learned something useful in this lecture, and I'll see you in the next one.